Discover the inner workings of PLC logic and scan cycles and unlock a deeper understanding of industrial automation. We delve into the world of programmable logic controllers, exploring the intricacies of scan cycles and how they execute PLC logic. Learn how PLCs process inputs, execute programs, and update outputs in a continuous cycle, and gain insights into the programming and configuration of PLCs. Whether you're an experienced engineer or just starting out in the field, this video will provide a comprehensive overview of PLC logic in scan cycles, helping you to improve your skills and knowledge in industrial automation. When a PLC scans a rung with multiple series contacts, it stops evaluating the rung as soon as it finds a false condition. This means that if you have a series of 5 contacts and the first one is already false, the PLC will not even check the other 4. Therefore, by placing the contacts that are most likely to be false at the beginning of the rung, you can save valuable microseconds of scan time on every single scan, which adds up to a surprising amount of efficiency over time. At the heart of PLC programming is the execution of the PLC logic. The running of the PLC controller is also known as the scan. Scan and scan time are essential to understand an automation. Scan cycles run cyclically. This means that they repeat continuously at a very high speed, which allows for real-time control of your automation project. There are many common misconceptions about what happens during PLC scan cycles. The PLC sees all inputs and updates all outputs simultaneously. Scan time is always constant, or all inputs and outputs are updated in the same order as they appear in the program. PLC scan cycles are critical to understand for responsiveness and timing, troubleshooting, and program optimization. The concept of a scan cycle is central to how PLC logic operates. A PLC doesn't process its logic all at once, it does so in a continuous loop or scan. Each scan cycle consists of 3 primary steps. 1. Read inputs. The PLC checks the status of all its input devices. It first reads all inputs and stores their status in an input image table. If an input changes during this time, the input image table will not update until the next scan of the input. 2. Execute logic. It runs the user-defined program from the beginning to the end, using the input image table data it just gathered. If we look at ladder logic, the logic is solved left to right, top to bottom. The output image table is updated as the logic is solved. These changes are available for the next rung of ladder logic to use. As mentioned, when solving the logic, if any of the series inputs result in being negative, then the output is immediately updated in the output image table. This execution creates the fastest possible time to update, and so the scan is not normally constant. 3. Update outputs. It writes the new status to all the output devices based on the output image table results of the program execution. This entire process repeats continuously and at very high speeds, which allows for real-time control of the automation system. The PLC reads all inputs before executing the program logic and then updates all outputs after the logic is complete. The order of instructions within the program itself can affect the internal logic, but the physical I/O is handled in a set sequence during each scan. The PLC scan cycle is a sequential process. It first reads all inputs and stores their status in an input image table. It then executes the program logic using the data from this table, not the live inputs. Finally, it updates the physical outputs based on the results of the program execution. This means there is a slight delay between a change in a physical input and the corresponding change in a physical output. Understanding this concept of PLC scan is critical for you to enhance system responsiveness, increase reliability and predictability, and improve troubleshooting of your system. Let me know your thoughts and comments below. There are many different PLC manufacturers with their own hardware and software. All programmable logic controllers share similar basic features. To learn how to approach learning about basic PLCs, click here. Click here to learn more about how PLC simulators can be used to help your programming skills.